Hey guys, welcome to question FM 305 of the Further Maths Fortifier Study Guide. This question reads, the diagram below shows a rectangular based right pyramid, A, B, C, D, E. In this pyramid, AB is equal to DC, which is equal to AE, which is equal to BE, which is equal to CE, which is equal to DE, meaning that all of those side lengths there are 20 centimeters. The length from O to E is 16 centimeters, and A to D is equal to CB. We're then asked the volume of this pyramid in cubic centimeters is closest to what? So, in order to find the volume of a pyramid, what we normally need to use is a formula which looks like this one, which is 1/3. Now, since this is a rectangular pyramid, 1/3 times length times width times height is going to do the trick for us here. What you will notice, however, is that we have a length, but we don't actually know the width of this rectangular base. So we don't know the length from C to B. All we know about the length C to B is that it's the same as the length A to D. So what we're going to have to end up doing is creating triangles, specifically right angle triangles within this pyramid, in order to end up figuring out what this length here is from C to B. So we've got L, we've got H, we need W in order to figure out what the volume of this pyramid is going to be. So just quickly below that, you guys may be used to using your Pythag formula, which is A squared plus B squared equals C squared. I prefer to use an alternate formula just so we can get straight to an answer of C rather than having to deal with all the squared stuff, which is C is just equal to the square root of A squared plus B squared. Or if I'm trying to find a length that isn't the hypotenuse, I'll use A is equal to C squared minus B squared, square root of C squared minus B squared, like that. So depending on whether I'm finding a hypotenuse or I'm finding one of the other side lengths, I'll use either one of these formulas. That's what I'll be using for the rest of this question. So moving on from there. Now, if I'm going to find CB, one of the easiest right angle triangles for me to create would be to use AB here and then the length AC. So what I'm going to go through now is just a series of steps, because I also don't know the length of AC. However, I can find it if I can find the length of AO, which I can find given that I have this height and this hypotenuse length here. So in order to find the length AO, which is going to be equal to the square root of, now I'm using this formula here, finding a side length that isn't the hypotenuse, because that would be this 20 centimeters here. So I'm finding A to O, and I'm going to be using AE squared minus OE squared. So, plugging in their actual values, this is going to be the square root of 20 squared minus 16 squared, which plugging that into a calculator should give you an answer of 12 centimeters. Now, we know that AC is just going to be equal to 2 of those AO lengths, which means it's going to be 2 times 12, which means it's going to have a length of 24 centimeters there. From here, so I've got my AC length there. So from here, I can actually figure out that length BC. So BC is going to be equal to the square root of AC, because that will be the hypotenuse in this right angle triangle here. AC squared minus AB squared. So this is going to be equal to the square root of 24 squared minus 20 squared, which gives us an exact value of 4 root 11 centimeters here. So now that I've found a BC, which is my width, I can plug it all back into my volume for a pyramid. So my volume for a pyramid is going to equal 1/3 times times, now we've got a length here of 20, got a width there of 4 root 11, and we've got a height of 16. Plugging all of that into a calculator should give you an answer of roughly 1415.09 centimeters cubed, which of course looks most like our answer A. That's all there is to this question, guys. If you have any further questions for us, please drop them in the comments below. Otherwise, I'll see you in the next video.